This call is now being recorded.
We have a molecular formula here, C4H question mark. I want to walk through the different calculations of determining the number of hydrogens, if this was an alkane, an alkene, or an alkyne. We have 4 carbons in our structure, and because carbon bonds 4 times, most of the time, every time, we can deduce a little math formula to determine whether it's an alkene, ane, or ine. So C4H question mark, if we know the number of carbons, in this case 4, we can take that number of carbons multiplied by 2 and then add 2 more. And that will give us the number of hydrogens. So there are 4 hydrogens in here. That should give us 8. There are 8 hydrogens in this compound here. If we draw out a picture of that alkane with 8 hydrogens, here's a little molecular model of those of it as an alkane. Note how it's in a zigzag conformation. It's not a there. It does look like a line, but it's in a zigzag conformation. Note that it can twist. Every single one of these single bonds can twist around. This is butane. And if we draw this out here, carbon, 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 and fill in our hydrogens, noting that carbon bonds 4 times every time. Each carbon is bonded 4 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I did this math here incorrect. 4 times 2 plus 2 equals 10. Drawing the picture is very helpful. What if we were told this is an alkene? There's a little formula we can do, and let's draw the picture. The little formula we can do for that is if we know the number of carbons times 2. That'll tell us the number of hydrogens for a straight chain alkene. Okay, let me get my calculator out for this one. 8 hydrogens. Let's do that in a little drawing. 1, 2, 3, 4. We're told it's an alkene. I'm going to put in the middle there and fill in my hydrogens for everyone else. Note that these carbons in the middle here, they only need 1 hydrogen to make their 4 bonds. 1, 2, 3, 4, 5, 6, 7, 8. And that works out right there. Here I have the double bond in the middle. And what's interesting about a double bond in the middle is this has that zigzag, but you have this twist. It's very rigid. There's 2 bonds in between there, 1 sigma, 1 pi, and there's a rigidity to that molecule there. And there's also some different conformations that can occur. So for example, this is still 4 carbons and an ene, but this has a much different configuration. It is a geometric isomer. This is the cis, and this is the trans isomer. Let's finally do alkynes. There's a formula to calculate the number of hydrogens. -2. See the little pattern here? Alkanes have the most hydrogens, so it's 2n plus 2. Because there is a double bond in alkenes, you take away 2 hydrogens. Because there's a triple bond, you take away 2 more hydrogens. So plus 2, 2n minus 2, 6. And let's draw it out here. And I'm going to keep my bond in the middle here. So see in the middle here, these carbons don't need any hydrogen, so we're not going to draw any hydrogens on them. They already are bonded 4 times. 1, 2, 3, 4. 1, 2, 3, 4. This carbon is bonded 4 times. This carbon is bonded 4 times. Let's fill in the hydrogens for the rest of the carbons. Now this guy is bonded 4 times. And this guy is bonded 4 times. And this is what this guy looks like a pipe, very linear geometry here. With 3 bonds in the middle, this is even more rigid. There's 1 sigma and 2 pi's. There's no twisting that can occur, a little bit of bending and wagging there. These at the end right here can twist. I don't have hydrogens on here, but this bond is definitely twisting here. Thank you.